What is up? It's your boy the Canologist. We're doing another code study session, OSRS AFK training. Cutting U's right now. Alright, let's look at net HTTP. Net HTTP, go standard net HTTP package. Okay, so it comes with it, it looks like. We've already been using it. The HTTP GET function uses the HTTP default client under the hood. So net HTTP is the library. But the thing with Golang is you still have to import it. So even though it's a built-in library, like it says, go standard net HTTP library. We're going to be using it. Still need to import it. FNT-IO, input output. Okay, get projects. And then I'm guessing this net HTTP. So net is the actual package, and then HTTP is the portion of the package that you use. So if we look at the whiteboard real quick, let's share screen. This is the package. And then this is the part that you use. So it'll be like, let's go back here. I want to show you what part gets used. So this part is the part that gets used, not this. And that is just the main import package, and we're just using HTTP from there. So if we go back, notice how it's like this, response, and then http.get. So it's http package.get, then runs an error if it doesn't work, res, so response, takes the success case, body, the body from that response, and then close. Defers that. So first we want to do work with it. So read everything from the body, then dispose of it. This defer keyword happens later in the code. We'll go in depth on the various things happening here later, but let's cover some basics right now. HTTP GET uses the default client to request the given URL. Request means I want to get data. And response is the, so request isn't necessarily getting data. Request is just notifying the server of what you want to do. The response is what the server brings back. It's like, okay, I want to get data, I want to post data, I want to delete data, I want to update. You have to make a request to the server. It doesn't matter what it is. So you got to imagine the restaurant. So HTTP GET uses to make a request. Rest is the response that comes back from the server. Defer ensures that the response is properly closed after reading. So this tells you that defer basically tells you we want to close this because you have to save resources, but I want to do all this work first and then close it, then return. Not doing so can cause memory issues. That's why you want to defer it. You have to close once you've made a request because that channel is now open. IO read all reads the response body into a slice of bytes. There's a bug in the get issue data function. It's returning the entire HTTP response instead of data from the body since it's a slice of bytes. Fix it so that it returns byte. Use IO read all to read the body of the response, return the byte. Okay, so let's go back to here. This is response body close, and then we just go to the what's it called? Get projects, get issues data, byte error, HTTP get URL. Okay, so it's taking data from a URL. This is the error case. If there's no error, I just want to read the body. So right now this is the success case. I need to do an IO read all. So basically we just do what's in the example, data error. So data error. This is IO dot read all. So notice that these capital letter functions are functions that are exported, so you can use outside. If a function is lowercase in Golang, it's probably internal to the file. It's a little bit different than JavaScript, which... So now we want to take the success case here. And then we want to just get the body. Response.body. Read the dot body of the response. So response dot body. It already kind of gives you the answer. And then if there's an error, this is just a feature of Golang. If error is not nil, because if error is nil, that means there's no error. If error is not nil, that means there is an error. It's kind of the opposite of what you're trying to do. Then return nil response, and then fmt dot error f. And then data gets the response body read all. So that's going to be passed here. Error F. Error reading response body, because that's exactly what it does. Then you just go here. Percent. If you don't know what to use for this value, just put they put W here. So Golang. W is a verb, special format for error wrapping. Wraps. Is wrapped within a new error. This means original error is accessible for later inspection. Okay, so let's just use that, the same convention. Or you could just use V, %V. That works too. I'm just gonna use W. And then just put error, because it's scoped to here, so it's not going to conflict with this. And people are asking, why don't we do response here? Why don't we defer it here? So if you only defer on what's making the request. We've already kind of gotten the response back, so now this is waiting to close, and we're just going to convert the data from here. So this closes after we do all this stuff. That should work. Okay, one sec. I'm just gonna keep it on my face because there's a video here. So you can like watch me staring at the screen while I play the video, because of fair use and all that shit. I don't want to play another person's video on my stuff, you know? And let me turn. Done watching the video, so now I can turn my shit back on. Let's look at this. We discussed client web server making requests. Client can be any type of device, but it's often something the users physically interact with. Desktop, computer, mobile phone, tablet. In a website or web application, we call the user's device the front end. Yeah, usually front end is whatever the user is basically using. It's front end. It's on the front line of like what the user sees, touches, interacts with. Back end is what the user wants from the front end, like data, like all the logic, all the rules, right? Like that's handled on the back end, and the user just sees what's on the front end. In a website, we call the user's device the front end. So front end of a website is the client. Front end client, back end server. But yeah, I just didn't want to put someone else's video on this because just out of fairness, I did also get permission from Lane to use boot.dev for my videos and stuff. So that's all kind of covered. Just for the video purpose, like I don't like recording other people's videos unless it's going to be explicitly a reaction. Fair use, fair use, fair use. All right, anyways, let's go back to this front end. front-end client. And then back-end. Back-end server. And then a mobile phone is often used as a client. And then web servers. Okay, let's look at web servers. Yeah, let's go with web servers. I'll put this here in my notes. Up until this point, the data you have used. Trained locally, while you've always used variables to store and manipulate data while your program is running. Most websites app use a server to store, sort, and serve the data that sticks around for longer than in a single session. Web server to store, sort, and serve. Okay, so store. Sort and serve data so that it can be sticks around for longer than a single session and can be accessed by multiple devices. Listening and serving data. Yeah, see, they use the restaurant thing too. A restaurant brings your food to the table. Web server often serves web resources. Server is turned on and listening for inbound requests. So the second it receives a request, you can send a response. Server is the backend. Server is the backend. Let's see. Well, the front end of a website is web application. The device that interacts with the backend is the server. While the front end of a website or web application is the device the user interacts with, backend is the server that keeps all the data housed in a central location. Server is just a computer. Taking on the role of serving data across the network connection. Good server is turned on 24/7. "24 hours a day, 7 days a week." Laptop can be used as a server. It makes more sense to use a computer in a data center. Laptop or Raspberry Pi? Better to use a computer in a data center. Always. Good web servers listen. So 24 hours, 7 days a week. So that'll be always. A server is the back end of an application. Any computer can be a server, but the best servers are made for serving data. Yeah, the best servers are made for. False, computers in data centers can be servers. Only computers, no. False, all computers are equally good, no. So true. You want to get a specialized computer that acts as a server. Like, people do use Raspberry Pi, but it's not as good as a data center, you know. That's why all these big tech companies use data centers. Because they're 24-hour, they've got 24-hour maintenance support, like a bunch of, it's got its own fueling capability, usually in these data centers, whereas your Raspberry Pi, if the power goes out, your server's down, you know. Chapter 2, JSON, okay. Let's get the crayon. Okay. So the next thing would be JSON. And I think I could separate this in another video. I'm going to call this guy JSON syntax. Well, we'll continue this in the next video, so stay tuned. Peace.